Good morning, guys. Now we're going to use those fundamental trig identities that we looked at in the last lecture to actually start verifying or confirming that one side of a trigonometric expression is equivalent to another side of a trigonometric expression. Multiple techniques we're going to look at in this lecture, changing everything to sine or cosine, using factoring, combining fractional expressions, changing the numerator and denominator of a single fraction, and then working with both sides separately. Okay, guys, first technique we're going to look at is changing everything to sine or cosine. We know that based on all of our identities, everything relates back to sine and cosine somehow, whether it be reciprocal identities, the quotient identities, or with Pythagorean identities. We can all turn it back into some relationship of sine and cosine. So that's the first technique you can always go with. So let's say that we have secant here. Secant we know is the reciprocal of cosine. So I can write this as 1 over cosine of x. Cotangent, if I turn it back into sine or sine and cosine, is going to be cosine of x over sine of x. And then keep cosecant of x. Let's just leave this right-hand side alone. Typically, what we're trying to do to verify, we're trying to show that this side is equivalent to this side. So let's just pause over here. We're not messing with the right-hand side and focus on the left-hand side right now. Well, if I'm looking at these two fractions, remember to multiply fractions, I'm going to combine my numerators, multiply them together. So I get 1 times cosine is cosine of x over cosine of x times sine of x. Well, we notice I have a factor of cosine in the numerator and a factor of cosine in the denominator. They'll cancel, just like I would any number, because cosine of x is some value for both the numerator and denominator, same value. So in the numerator, I'm left with 1 over sine of x, and what's 1 over sine of x equal? By the reciprocal identities, it equals cosecant of x. So we can see cosecant of x equals cosecant of x. So we've used substitutions from our fundamental trig identities on the left-hand side to show that it's equivalent to the right-hand side. So that's all verifying. It's showing that one side is equivalent to the other side. Let's look at number 2 here. I've got sine x tangent of x plus cosine x equals secant of x. So let's change everything into sine and cosine. So this tangent of x right here, sine of x won't change. This becomes sine of x over cosine of x plus cosine of x, and we'll just leave the secant of x over on the right-hand side. Well, just like before, put it over 1, sine times sine is sine squared of x over cosine of x plus cosine of x. Now, this is a strategy. This uses another strategy we're going to look at next, which is just adding fractions together. We'll get fractions to combine. We have to have the same denominator. So cosine of x and 1, I need to make this times cosine of x, top and bottom. Now I have 1 cosine of x and 1 cosine of x for both denominators. It's going like we did all our rational expressions we did units or months ago. Keep your denominator, combine your numerator, sine squared x, cosine becomes cosine, is cosine squared x. And then sine squared plus cosine squared, because of our Pythagorean identity, we know is equivalent to 1. So it's 1 over cosine of x. And we're trying to get the secant of x, which by the reciprocal identity, 1 over cosine of x equals secant of x. So this isn't some magic trick where I'm taking this stuff to make it equal the same thing. All we're doing is just substituting our identities in, and we're using the strategy of change everything into some identity, some relationship of sines to cosines. So that's the first technique that we always kind of check for. It's usually your easiest one because everything does relate back to sine and cosine. Okay guys, the next strategy we're going to use is by factoring. Now if I look over here on the right hand side, it's the simpler side. So it's easier for me to say, if I can combine all this stuff together to get this expression, I should have an easier route. So factoring, notice I'm going to use because I have multiple terms. Multiple terms, meaning I have pluses and minuses involved, that I need to become one term. I can either add them together, right? 2x plus 3x is 5x. Or if they're different type of expression, 2x plus 3y, I've got to find another way to get them to combine together. And that's what factoring does. It takes multiple terms and turns them into multiple factors. But if they're factors, it's all multiplication, so we can combine them all together that way. So if I'm looking at this, I notice that each term has a cosine in common. So that would be a common factor of cosine. So if we factor out the cosine, remove a cosine from each term, that's going to leave me 1. That's going to leave me minus sine squared of x. So just like if I had x squared plus 2x, and I pulled an x out of each term, factoring x out, and that leaves me x plus 2, it's the same thing I have right here. Remove a cosine, divide a cosine out of each term, and I'm left with 1, because that has an understood coefficient of 1, and I'm left with a sine squared. Well, how does that help me? Well, I'm trying to get to cosine cubed. Well, I've got cosine to the first here. Now, I need this to be something with cosine. Well, this should look familiar to me, 1 minus sine squared, because 1 minus sine squared, or 1 and sine squared are held together by our Pythagorean identity. Remember, sine squared x plus cosine squared x equals 1. Well, I can rearrange this, which we talked about in the last lecture, by moving sine squared to the other side. And what does 1 minus sine squared of x equal? Cosine squared. What are we trying to get to? Cosine cubed. So that is how the factoring can put me into something that can combine and give me this. So we're going to do a substitution here based on our Pythagorean identity, that 1 minus sine squared equals cosine squared of x. So cosine of x times cosine squared of x, cosine times cosine squared should give us cosine cubed of x, which is equivalent to cosine cubed of x. So this is our whole verification. Remember, verification is not just this bottom line, cosine cubed equals cosine cubed. Verification is all the steps. All of this is our answer. All the steps it takes to get us from here down to here to show that the left is equivalent to the right. This whole thing is our answer to this verification problem. Okay guys, now the next thing we're going to look at is combining fractional expressions. We used this a little bit in the first example where we changed everything from sine to cosine. We're going to go a little more in depth with it here. Notice again, on the left side I have the more complex expression. On the right side I have the real simple 2 times secant of x. So I want to be focusing on ways to take this and combine them together to get this single term. Well, the easiest way to combine two things that have a plus sign is to add them together. Well, we've got two fractions. We know that to add fractions, I have to have that common denominator. Now, notice that if I look at these denominators as factors, 1 plus sine of x is one factor, cosine of x is the factor of the second denominator. Those factors are not in common, so I need to just multiply them together. Just like if I had a denominator of 2 and a denominator of 3, I've got to multiply them together to give me an overall denominator of 6. We're going to do the same thing here. 1 plus sine of x needs a cosine of x for top and bottom. Now I have 1 plus sine and cosine. This cosine of x needs a 1 plus sine of x for top and bottom. Now we have identical denominators. Identical denominators now means we get to combine those numerators together. So I get to take my cosine x, which would be cosine squared of x, plus whatever I get from this. Remember, it's entire numerator times that new factor. So we distribute and combine like terms. 1 times 1 is 1. 1 times sine is sine of x. So we're going to just distribute 1 sine of x plus another sine of x is 2 sine of x's And sine of x times sine of x is sine squared of x. That's my entire numerator over my common denominator of cosine of x times 1 plus sine of x. I'm going to hold off and distribute that in a minute. A lot of times what happens is things in here will cancel out from the denominator. Obviously, we need to put all the numerators together because that's the biggest, ugliest part. So we need to see if there's something we can simplify. But kind of hold off on those denominators until you really absolutely have no further steps you can do, and you have to combine those together. So let's look what we've got up in the numerator, see what we can simplify. Something I noticed is I have a cosine squared and a sine squared. We know by the Pythagorean identity that sine squared plus cosine squared equals 1. So we can just do a substitution to where it's 1 plus 2 sine of x over cosine x 1 plus sine of x. Okay. Well, that's helpful because 1 plus 1 is obviously 2. 2 plus 2 sine of x over cosine of x times 1 plus sine of x. So we're getting closer to the 2 secant of x that we were wanting to get to. Let's pull this up here so we have a little more room to work. So I'm now sitting at 2 plus 2 sine of x equals 2 secant x. All that was over cosine x times 1 plus sine of x. Now I just need a single 2. I don't need a 2 plus 2. So I've either got to get plus 2 sine of x to completely cancel out, which we know that can only happen if I subtract 2 sine of x. That's not likely to happen. Or if I can take these two 2's and combine them into one 2. Well, it's just like we talked about on the last example where we were doing the factoring, that I can factor that common 2 out, and I'm left with 2 divided by 2 is 1. 2 sine of x divided by 2 is sine of x over cosine of x times 1 plus sine of x. Why is that significant? 1 plus sine over 1 plus sine, because they're both factors. They're being multiplied by the remainder of the numerator and denominator. Cancel, and I've got 2 over cosine of x. Well, does that really help us? Yeah, I mean, because now I need to somehow turn this into 2 secant of x. Well, this is 2 times something, so let's set that 2 off to the side and make that 2 times 1 over cosine of x. So just pull the 2 out of the numerator to 2 times, and what's 1 over cosecant of x? Secant of x because of our reciprocal identity. So that's 2 secant of x we have shown is equivalent to 2 secant of x. And now you can see there can be multiple types of identities within one problem. There can be multiple strategies as far as changing things into sine and cosine, having to do factoring in there. But it doesn't really matter how we get there as long as I can take it from this expanded form at the beginning down to my final form where I show the left side is identical to the right side. Now sometimes, guys, we'll get an expression where it's just not very obvious how we're supposed to go through it. There's nothing that obviously factors out. We don't really have two fractions, two fractions on one side of the equal sign that we can combine. Not really anything we can factor, just nothing obvious that you can do. Well, you can just start looking at the form. Something already matches in these two. Got a fraction equivalent to a fraction. Only difference is I have a sign up here, sign up here on the left, and on the right I have a sign on the bottom. I have a 1 plus cosine down here, and a 1 minus cosine up here. So one strategy you can use is just change it into what you want it to be. Okay, now, the reason I can do that is if I use sound math techniques, math strategies, then we can, it's all going to hold equivalent. Now, I can't move things from one side to the other because we don't know that it's equivalent. When we're verifying, remember, we're trying to show that they're equivalent, so I have to rearrange one side so that it looks like the other side. So without moving anything across the equal sign, I'm still going to use that idea of put things in the same position. So notice how we'll focus on working with the left-hand side. Notice on the right-hand side, I've got 1 minus cosine over sine. Well, I don't have a 1 minus cosine in this problem. So let's put one in the problem. And so I need a 1 minus cosine in the numerator, so I'm just going to write times 1 minus cosine of x. Why can I do that? Well, because if I put it in the denominator also, I'm realistically magnifying the entire fraction, numerator and denominator, by the same value. How is that helpful? Well, up top I've got sine of x times 1 minus cosine of x. Not going to distribute that because I want that 1 minus cosine of x to stay. On bottom, 1 minus cosine of x times 1 minus cosine of x. I'll go ahead and distribute that one. 1 times 1 is 1. Minus cosine plus cosine cancels. And I get minus cosine squared of x. So I've got the 1 minus cosine in the numerator like I've shown for this expression I need. Now I just need to figure out how to get rid of that sign and get another sign on bottom. So 1 minus cosine squared should look familiar to you. That's a manipulation of that first Pythagorean identity. Remember, sine squared plus cosine squared equals 1. And we said I could subtract that cosine squared over. So that 1 minus cosine squared of x is equivalent to sine squared of x, which is very handy because I need a sine on the bottom. Well, if I've got sine squared on bottom and sine on top, 1 sine on top cancels with 1 sine on bottom, so I've got 1 minus cosine of x over sine of x, which is exactly what we were trying to get to. 1 minus cosine of x over sine of x. So even if there's not obvious things to change or obvious ways to combine, if the forms are similar like we have here, just put something where you need it to be and then do the appropriate math to make that legal. To counteract putting it in the numerator, we're going to also put it in the denominator, balance it out. So that's how we can change numerator and denominator in a fractional expression to simplify these things. All right, lastly, we're going to combine a lot of these strategies that we've been working with to actually work with both sides separately. A lot of times you don't have one neat side and one complex side. You may have two complex looking sides such as we have here. We're all need to perform different types of strategies on different sides. The key is just do something. So I would feel it's obvious that we should probably combine these two fractions together just so we can get something that we can actually do some substituting for. Because right now, all I can do some substituting for is for cosine, where I could put 1 over secant in. Well, we know we're not trying to get to anything with 1 over secant, so there's not really much substitution I can do there. So let's see if we can combine these two fractions together. Just focus on the left side for a minute. So again, it's get a common denominator. So I need 1 minus cosine of x to the top and bottom on the 1 plus cosine of x onto this fraction. So I get my first numerator, 1 minus cosine of x, plus 1 plus cosine of x, all over my common denominator. What's my common denominator? Whatever 1 plus cosine of x times 1 minus cosine of x is equivalent to. Now, as I work through this, plus cosine and minus cosine actually cancel out, and I get 1 plus 1, which is 2. 2 over, now 1 plus cosine, 1 minus cosine doesn't really do anything for me, but if I will distribute that, and because we know we should be at the point in our math training that we can see these as conjugate pairs, just the middle sign is opposite, so it's a difference of 2 squares. So that's 1, and then minus cosine plus cancel, plus cosine cancel, and we get minus cosine squared of x. All right, so we've simplified that down to something rather neat. Now if I look over here on the right-hand side, we can simplify this one down using our factoring, right? There's a common factor of 2. So if I pull a 2 out, I'm left with 1 plus cotangent squared of x. Now, that doesn't really do much for me, but cotangent squared, based on our Pythagorean identities, if we go back and look, 1 plus cotangent squared is cosecant squared. cosecant squared, which is a nice, easy relationship. So let's finish this off and see if I can get it to be 2 times cosecant squared. Well, 1 minus cosine squared, based on our Pythagorean identities, is sine squared of x. And we've already worked with this. Set the 2 off to the side, and 1 over sine squared is going to give me cosecant squared of x, which is equivalent to 2 cosecant squared of x. So we can see in this example that I can simplify the left-hand side down, get it into something nice and neat. Don't have to go all the way to the end because I don't really know what the end is. Then start working with the right-hand side and see if I can just kind of do a little bit at a time so they start working closer and closer to becoming something that's going to become identical or equivalent. Now remember, you're not going to have to memorize all of these identities. Whenever you're working with these, have your identity sheet with you. And there's a link on my webpage. You can just download a copy of it. But have your identity sheet with you and just check back and forth again and again and again, just working through, do something when you're verifying. You can't verify and know exactly how to get to the end just by looking at the original expression. Just put something down. Even if it's not going to get you to the end in 2 steps, they're equivalent. It's all going to get you to the end at some point. 2 plus 2 is always equal to 4. So as long as I use some true expression to do my substitutions, it's all going to come out equivalent in the end. So do something, simplify that something, and then you can do some other something, and you'll, after practicing with these enough, you'll start to be able to see kind of a step or 2 in advance where you need to go. But you've got to practice them, and you've got to just do something. I'll see you in class tomorrow, guys.